Hello everyone, this is lesson 9.2, part 2. We are going to learn how to do some problem solving with quadratic functions. So my Smart Slate is, right now it is dead, so I'm going to need to type. I don't think that'll be a problem, but the little thing I usually use to write on is not working this morning. So this first example, it says a baker has modeled, also there are no notes for today, so you'll just write this in your notebook. So a baker modeled the monthly operating cost for making wedding cakes by the function that, where y is the total cost in dollars and x is the number of cakes prepared. So one thing that I want to emphasize again is that when you're taking your test or quiz, keep in mind that Desmos might be disabled for you, so you can't rely on Desmos to figure out the problems. Instead, you can use your graphing calculator or learn how to do it by hand. So, however, one thing I do want to do is show you what this graph looks like. So currently, I am graphing it in Desmos. I'm going to pull it over to the screen and show you what this looks like. So he said it's the baker's operating cost. So what's happening here is that, and then is it per month? X is the number of cakes prepared. Y is the total cost in dollars. So this is just the number of cakes he prepares. So as the number of cakes he prepares increases, the cost in dollars decreases, and then it comes back up. This is just the trend that he sees. So that's what this function looks like. So what is the minimum operating cost? Okay, so whenever it asks you to find a minimum or maximum, it's asking you to find the vertex. So whatever you see minimum or maximum, find the vertex. Remember, if we want to find the vertex in standard form, you have to use negative b over 2a. So here we would have negative b, which is negative 12, over 2 times a, which is 1/2. And 2 times 1/2 is 1, so the negatives cancel out and you just get 12. Now, that would be the number of cakes, so 12 cakes at the minimum operating cost. But then if you want to find the operating cost, that's the y. So you would need to plug 12 back into your function. You can do it by hand. It's not that hard. You just do 12 squared is 144, multiplied by 1/2, minus 12 times 144 plus 150. Or you could take your calculator and type it into your calculator. So I'll show you what I mean by that. So you could do 1/2 times 12 squared minus 12 times 12, and then plus 150. So $78. So $78 is the minimum operating cost when you've got 12 cakes. How many cakes should be prepared to yield the minimum operating cost? Well, guess what? We already found that answer, 12 cakes. Okay, so this is one of those things also where if you try to look for the minimum or maximum in your calculators, like in the table, it might take you a while to find. And plus, what if you end up getting a decimal? Then you're not going to be able to find the answer. So what if you got a decimal for negative b over 2a? All right, so let's do another example. We're going to skip some of this stuff. That's not what I thought I had up here. Let's try this lesson. Is this what we want? No, you know what? I'm just gonna put it up here. So the next example says fishing spiders can propel themselves across water and leap vertically from the surface of the water. So you've got a spider, it's going like that. So the function that models this situation is y equals negative 4,500 x squared plus 820x plus 43, where x is the duration of the jump, so x is in seconds, and then y is height of the spider in millimeters above the water. How many seconds does the spider reach its maximum height? So when does it reach max height, and what is max height? So once again, if it's asking for the maximum, then we're going to find the vertex of this equation. So we would use our vertex formula, negative b over 2a, so negative b is 820, over 2 times a, which is 4,500, negative 4,500, and that should make sense because then the negatives will cancel. Now for this one, I'm going to go ahead and just plug this in my calculator. So I'm going to do, you could use your fraction button and just do it all in one step. If you don't have a fraction button, you would do simplify the denominator. 2 times 4,500. Wait a second. I have one extra zero. Is 9,000, and then do 820 divided by 9,000, and you get that. Okay, so 0.091. And does it say rounding? It doesn't really give rounding directions, so that should be fine. So that would be the seconds that it reaches its maximum height. Okay, you wouldn't expect it to be too big, right? It's just a little spider. And then to figure out the maximum height, we would plug 0.091 back in for x. So I would do negative 4,500 times 0.091 squared plus 820 times 0.091 plus 43. And then you get 80.3, we'll call it 80.4 to round millimeters. Okay, so that would be the answer for that question. All right, let's do one more. So this one says students are selling packages of flower bulbs to raise money for a class trip. Last year when the students charged $5 per package, so when they did $5 per package, they sold 150 packages. The students want to increase the cost per package. They estimate that they will lose 10 sales for each $1 increase in cost per package. The sales revenue in dollars generated by selling the packages is the function R equals parentheses 5 plus n and then 150 minus 10n, where n is the number of $1 increases. Okay, so this is a little bit confusing, so let's look at what's going on here. So revenue in this case is going to be, so it says 150 minus 10n. That's because you start with 150 packages and it says 10 sales for each $1 increase in package. So if you've got $5 per package, makes 150 packages. And then they're saying that if you're going to lose 10 sales for each $1 increase in package. So they're saying that the higher the cost is, less money less people are going to buy. So, or the less money overall. So this is the 150 minus the 10n, and then 5 plus 10, that's the $5 per package, plus n number of $1 increases. Okay, so it says first write the function in standard form, get rid of the parentheses. Okay, so if we want to write this in standard form, we would FOIL. So 5 times 150 is 750. 5 times 10n is minus 50n. And then the inner is plus 150n. And then the outer is minus 10n to the second. If we simplify and rewrite in standard form, you put the negative 10n to the second first, plus 100n, and then plus 750. Okay, so that would be the function in standard form. Now this parabola is opening down like that because it's negative. And the next question says, find the maximum value. Find the maximum value. So if we want to find the maximum value, this is like the first question. You want to use the negative b over 2a. So negative b is 100 over 2 times negative 10. So first of all, the negatives will cancel. 2 times 10 is 20. 100 divided by 20 gives us 5. So 5 is when the minimum value occurs. So this gives us when the max occurs. In order to find the maximum value, the value is going to be your y coordinate. So we're going to plug in 5 back into our function here. So I'm going to pick up my calculator and go negative 10 times 5 squared, which is 25, plus 100 times 5, which is 500, and plus 750. So we get 1,000. And then that would be in dollars. $1,000 for the revenue. Okay. So that is, and then there's one more question here at the end, I'm sorry. It says, at what price should packages be sold to generate the most sales revenue? Well, if X is 5, then if you plug 5 back in for N, then 5 plus 5 would be 10. So they should be, this number represents the total amount for the revenue, total amount of cost per package for the maximum revenue. So that answer would be $10. Okay, so the moral of the story is if you're finding the maximum or minimum of a quadratic function, it's in standard form, you would use negative b over 2a and plug it back into your equation to get the y value, and then just make sure you, like if they're asking for the value, you state the y value. If they're asking for when it occurs, like time and seconds, you would give the x value. Okay, so that is all for this lesson. You guys have a great day.